Okay, this is a video for our Calculus 1 Differentiation in Class Practice number 14. And normally this is done on my TA Inspire. I would be sending this to you, but I'm going to do a video so you can see it and practice using our derivatives. This is very similar to number 63 on our Power Rule Practice Lab 1 that we just did. Power Rule Practice Lab number 1 that we just did. I just wanted you to know that because this is very similar to that, and I wanted to make sure you're comfortable with all the work. So I have this model rocket, and this model rocket is launched from a roof on a building. Its flight plan is modeled by negative 5t squared plus 40t plus 20, where h of t is in the height of the rocket above the ground in meters and t is in seconds. Graph the function and find when the rocket is at its maximum height and what that maximum height is. So first of all, I graphed this and I felt really cool because I could put in an actual rocket picture in here, so I played with that. I did this in quadrant 1, and I know this right here is 20 meters because this is my height in meters, and this is my time in seconds. Life is in quadrant 1, so I kind of graph that, and I know it's going to hit the ground eventually. So we're going to go through each one of these questions and how we solve them. So the first one, they want to know the average velocity. So I realize that velocity is my first derivative. So I have my function above there. So I know that f prime of t, using the power rule, is going to be negative 10t plus 40. So if they want me to find the average velocity in the first 2 seconds, I'm going to find, and the key word here is average, that when I want to find the average velocity, I want to find the velocity at 0. So this is our velocity equation. So I know I say v of t, because that's my first derivative, is negative 10t plus 40. So I'm going to find the velocity at 0 seconds, the velocity at 1 second, and the velocity at 2 seconds. And when I find all three, I'm going to add them up and average them. So I get negative 10 times 0 plus 40. That equals 40, and it's meters per second. Units are important. I plug a 1 in there. Negative 10 times 1 plus 40 is going to be 30 meters per second. And then I got negative 10 times 2 plus 40 equals 20 meters per second. So all these are meters per second. Okay? So if I'm going to average them, if I add all three and divide by 3, so 40 plus 30 is 70, plus that's 90 divided by 3, my average velocity is going to be 30 meters per second. That's my average velocity. All right? As the average. Now that's important because of the word average, which is different compared to find the velocity at 2 seconds. This is called our instantaneous velocity. Meaning you want to know the velocity right at 2 seconds. Well, we already did it. It's down here. We know it's going to be 20 meters per second. So they are different, and that's what we did right here. We already did the work for that. So I just wanted to show you there's a difference between average velocity and instantaneous. The next thing they ask is, what is the acceleration? Well, I know acceleration is my second derivative. Okay. And so I'm going to come up here and take the derivative of this, and when I do, I get a negative 10. And our units are going to be in meters per second squared because I took the derivative of the derivative. That's our acceleration. It's negative because it's down in a downward direction, and acceleration due to gravity does pull it down. In this questions, it's a nice number, negative 10. And if I want to find out what our acceleration is at 2 seconds, it doesn't really matter. It's always going to be negative 10 meters per second squared in this problem, because that's what it is for any time that we talk about. Now, this is the fun part here. I wanted to show you about this part, is using calculus to come up with this. And what I mean is, how high did the rocket go? So in pre-calculus, I had you do like the axis of symmetry, and then once you did the axis of symmetry, you could find the time and plug it back into your original. But now that we're in calculus, I do know when I look at this launching of this rocket that it's going to come up here, and right up at the very, very top, my slope is 0. My rate of change is 0. My velocity is 0. So what I'm going to do is use my velocity equation right here that I have, the f prime of t is negative 10t plus 40. I'm going to put that equal to 0 to find out, hey, when is the velocity 0? So I've got f prime of t, so I've got v of t equals negative 10t plus 40. I'm going to put that equal to 0 so I can find out when my velocity is 0. So I have negative 10t equals negative 40. T equals 4 seconds. So at 4 seconds, my rocket is at its high point. Now I'm going to take that, plug the 4 seconds back into my height equation to find exactly how high does this go. So I've got negative 5 times 4 squared. I'm going back to my original height equation, plus 40 times 4. So I put 4 in for the time each time, plus 20. And when I do that, I get 100 meters. So at 4 seconds, my rocket's at 100 meters high. Okay, so I'm going to come here and say, all right, this is 4 seconds, right here in the middle, 4 seconds, and this is 100 meters right here, is my height. Okay, so the point 4, 100 is actually my vertex of my parabola. Now, the last part of this is, so we talked about average velocity, we talked about instantaneous, we talked about acceleration, we talked about using our velocity equation to find how high it is. And now the last part is going to take you back, is they want to know how long this rocket was in the air. Well, I know the rocket was in the air until I hit the ground, right? So I know that taking my height equation, putting my height equation equal to 0 is going to give us when this hit the ground, and that's how long it was in the air. So I have h of t, this was our original function, was minus 5t squared plus 40t plus 20. I'm going to put that equal to 0. Now, when that's equal to 0, I can figure out what that is. Now, you can use the quadratic formula to actually come up with that. So what I did to do that is I actually factored out a negative 5 first. This is legal, to make my equation a little bit easier, smaller numbers to throw in. You don't need to do this. So when I stacked and racked, I had A was 1, B was negative 8, C was negative 4. When I did my B squared, 64 minus 4 times A times C, I got an 80. So I now know that my time equals negative B, which is 8, plus or minus radical 80, all over 2A, or 2. So when I did the positive and then the negative came out to be 8.472. The negative was negative 0.472, which we're going to reject because that's even before it was launched. So how long was it in the air? It was in the air 8.47 seconds. So that should take you back. Now, the last thing I'm going to do on this in-class practice is to do this is your last problem in your text assignment. It's page 182, number 61. But I thought it was worthwhile doing this because it's pretty neat how to do this. So we're going to kind of work backwards. So it says find a second degree polynomial, which I know is x squared, which I know is a quadratic. So they want us to find a quadratic. Well, I know that the quadratic basis of this equation is ax squared plus bx plus c. So they basically want us to find that using the information they gave us. So they gave us p of 2 is 5, p prime of 2 is 3, and p double prime of 2 is 2. Well, first of all, the x's are 2, and then they gave us information. So we're going to go through, do f then we're going to do f prime and then f double prime, use the information they gave us and kind of work backwards to figure out what this would be. All right, so let's do the first one. They told us p of 2 is 5. So this is my x, this is my y. So I'm going to say, all right, 5 equals a times 2 squared. I'm just plugging the 2 at every time there's an x. B times 2 plus c. So now I know 5 equals 4a plus 2b plus c. And I'm going to kind of stop right here because I can't do anything more with that. That's the information they gave us. Then the next thing they said, p prime of 2 is 3. So I'm going to do here f prime of x. So I'm going to use that right here from the blue and do the derivative. So that's going to be 2ax to the first power plus b. Now I'm going to take and plug in this information. So wherever there's an x, I'm going to plug a 2. Wherever there's a y, I'm going to plug a 3. So I have 3 equals 2a times 2 plus b. So 3 equals 4a plus b. So I'm going to stop right there because there's really nothing else I can do with that information. Now they have f double prime. So I'm going to go back to this, back to this one right here, the f prime, and I'm going to take the derivative of that. So f double prime of x is just going to be 2a. That's all it is because it's to the first power. Now I'm going to plug in what they gave us. It says p prime of 2 is 2. So I know this whole thing is 2, and there's no x here to plug in, so I know 2a is 2. So a is 1. Now this is kind of like a domino effect. Now I know a is 1. Once I know a is 1, I can now come up to here in the red, plug in a is 1 and find out b. So 3 equals 4 times 1 plus b. So b is going to be negative 1. Now I have that. Now that I know a is 1 and b is negative 1, I can come up here and plug this in and find c. So I have, right here, I'm going to use this for the black one here. So I got 5 equals 4 times 1 plus 2 times negative 1 plus c. So 5 equals 4 minus 2 plus c. 5 equals 2 plus c. So c is going to equal 3. Now, there we go. I now can go back here to this blue one right here. Go back to the blue and plug in everything we found. So we found f of x. A is 1, so I don't really need to put it. B is negative 1, so that's going to be minus x. And c is 3. So we found the quadratic function, or the polynomial, if you will, that used that information, and we kind of went backwards. So that's it for this video.